का बाकायदा आगाज़ करते हैं। आज की इस क्लास में हम प्रॉब्लम 5.4 करेंगे और स्टूडेंट्स की ये असाइनमेंट है प्रॉब्लम 5.7। This is the statement of problem 5.4. Suppose that the magnetic field in some region has the form B is equal to kz x cap, where k is the constant, and find the force on the square loop side A lying in the yz plane and center at the origin if it carries a current I flowing counterclockwise when you look down the x-axis. This is the solution of the problem 5.4. This is the formula which we will use here to solve this problem. And actually in this problem, this is the square loop and we have to find out the force acting on this square loop if this square loop is placed in the magnetic field B. The magnetic field B is along x-axis here. And you can see that current is flowing in YZ plane and magnetic field is along x-axis, and as a whole dl is the perpendicular to the magnetic field. So we can say that in this formula dl cross b is equal to dlb sine 90 is equal to dlb. Next slide. So f is equal to I dlb. B is the constant, so can be taken out the integral dl. What is the integral dl? Integral dl is the length of one side of the loop, and which is equal to a. So force acting on the one side of the loop is equal to F is equal to IBA. In vector form, we can write F is equal to IA cross B. Now we calculate the force acting on this upper side. This upper side, from this upper side, the current is flowing along negative y direction. And so length has negative y direction. And so we can say that A is equal to minus a y cap. A is equal to minus a y cap. And B is equal to Ka by 2 into x cap. Because in the problem it is given Kz x cap. Z is the z coordinate of this upper side. And z coordinate of this upper side is a by 2 because total length is a, and from the origin the z coordinate to this point is a by 2. So b is equal to Ka by 2 x cap. Putting this value here and putting the value of a, and then we get minus IKA square divided by 2 y cap cross x cap. Y cap cross x cap is equal to minus z cap. As you can see from here, y cap cross x cap is the cross product of unit vectors, and it is equal to minus z cap. And so F is equal to IKA square divided by 2 into z cap. Because multiplying these two negative sign, we get the force along z direction, having no negative sign. So force is along z direction, which is, it means that force acting on this side is upward. Now we want to calculate the force acting on this lower side. So what is the force acting on this lower side? we can also find out this force by using the same formula that we have used previously. A is equal to a y cap, because now the current is flowing along positive y direction, so A is equal to a y cap. B is equal to kz x cap minus ka by 2 into x cap, and y we have taken the z is equal to minus a by 2, because uh, position of this side is along negative z direction. Therefore, z is equal to minus z by 2 from here to here. So we have put z is equal to a by 2, and f is equal to I, putting the value of a vector here, multiplied by uh, putting the value of b here, and taking common all these, I a square k divided by 2 y cap cross x cap is equal to minus I a square k divided by 2, because y cap cross x cap is equal to minus z cap. So we have f is equal to I a square k divided by 2 into z cap. Again, force is upward direction, because force is positive now and force is again in upward direction. So on both sides, on this upper side and on this lower side, force acts in the same direction, and these forces are added up to each other. When we will calculate the net force, we will add these two forces to calculate the net forces. And in the next section, we will calculate the force on this side, which is the left side, and then we will calculate the force on the right side. So first we calculate now the force on this left side. If the current I is flowing in downward mean along the negative z direction. In this case, z coordinate is not fixed. Z coordinate is varying. If z was fixed previously, it means that b was the uniform, and at that time we can use this formula. But here we could not use this formula because b is not uniform. So we will use this formula to calculate the net force, which is the most general formula to calculate the force on the left hand side. So I integral dl minus z cap cross kz x cap, putting the value of b here, dl is equal to dl minus z cap, and dl is also along z direction, so dl is equal to dz here, and then we get this after arranging sum. So z in dz minus z cap cross x cap, and its limits are from minus a by 2 to a by 2, and we get here because z cap cross x cap is equal to y cap, so it is equal to minus I cap minus a by 2 plus a by 2 z into dz into y cap. F is equal to minus I k minus a by 2 to plus a by 2 z dz y cap. So force acting on this left hand side is equal to this, and now we want to calculate the force acting on the right hand side. Adopting the same procedure as we have, we get the force acting on the right hand side, this ik minus a by 2 to a by 2 z dz y cap. So you can see the forces are same, but these forces have negatives are opposite to each other. So magnitude of these two forces are same, but they are opposite to each other. So forces acting on a left hand side and right hand side, they are same, but these forces are opposite to each other, so they will be cancelled out. So net force is only due to upward side, and this upward side and this lower side, and we have calculated already these two forces. In the equation 1, we have calculated the net force, the force acting on the upward side, and we have calculated the force acting on this lower side. So adding these two forces, then we get the net force acting on this current loop. So net force acting on this current loop is equal to I K A square Z cap, which is also in positive Z direction. So net force is along positive Z direction.